Okay, the first thing I'm going to do is just get the center and the radius for those two circles. So the first one would be, excuse me, x minus 2 squared. It's x squared minus 4x plus y minus 3 squared. That's y squared minus 6y. That's a plus 13, but I need only a plus 5. Isn't it 4? No, it's not plus 13. What am I saying? Because that's, oh, no, it is. That's a plus 9. That's a plus 4. That's a plus 13. But I need just a plus 5. So I need a minus 8 here. Equals 0. Or in other words, this is equal to 8. Likewise, that's x minus 3 squared. X squared and then 3x and then plus y minus 4 squared, y squared minus 8y. That's plus 9 plus 16 is plus 25, but I need a plus 23, so I need a minus 2. So this circle here, that's root 8 squared, which is yeah, 4. Yeah, it'd be best just to leave it as 4 times 2. Four times 2, and this is 2. So this one here has a radius of 2 root 2, and this one here has a radius of root 2. Okay. And then the distance between the centers, d, that would be the square root of 1 squared plus 1 squared minus. Interesting. That's root 2. So if they were touching externally, let's just say this one is R1 and this one is R2, then what should happen is R1 plus R2 should be less than the distance. And then if they were touching, not touching externally, if they weren't touching at all, if they were touching externally, then R1 plus R2 should equal the distance. And then if they're touching internally, R1 plus R2 should be more than the distance. So I'm not asked to prove that it touches internally once, just that it touches internally. So I think it's kind of weird, but I think it's probably just enough to show that the sum of the radii is more than the distance. So R1 plus R2 more than D, 2 root 2 plus root 2 is more than root 2. It's 3 root 2. So it's true. So you have a picture like this. So this distance here is root 2. And then you've got another circle here. It must be, no, that's 2 root 2, because the smaller this other circle here, the smaller one is root 2. So that distance there is root 2, and the distance from the center of the big one to the small one is root 2. So yeah, this guy here is just clipped the center of the large circle. Find the coordinates of the point of contact of the two circles. Interesting. So where do they meet now? I wonder if there's some smart way of doing this. Is there some smart way of doing this? Some ingenious way? Yeah, I think so. So for this large circle, this is the point 2, 3. And then here for the smaller circle, this is the point 3, 4. And this distance is root 2. And this distance is root 2. And there to there, you add 1, so that becomes 3, 4. So this point here would be 4, 5. And then the other circle is sitting here. So yeah, the answer would be 4, 5. Oh, I'm going to check the answer. That was kind of brave. Yeah, I've just peeked at the marking schemes. The answer is 4, 5, but the way that they did it was the way I didn't want to do it, which was via simultaneous equations. So I kind of thought, that's kind of cool. I don't actually have to use simultaneous here and get the answer just from the diagram and translations. I like it. I like what I did, I guess is what I'm saying. All right, let's have a look now at the last part here. A circle has its center in the first quadrant. The x-axis is a tangent to the circle at the point 3, 0. The circle cuts the y-axis at points that are 8 units apart. Right, so here to here is 8 units apart. Find the equation of the circle. Okay, well here's 3. That's or. That's or. That's or. So I can, that's 3. So I can draw a little triangle here. The base of it's 3 and that's 4. So the radius is 5. So I know the radius is 5. So now I know the center. The center is at 3, 5. So I'm done. It's x minus 3 squared plus y minus 5. Sorry, not 5. Oh yeah, it's 5. Because I go out 3, go up 5. Yeah, 3, 5. Yeah, x minus y minus 5 squared equals 25. So done. Right. This was kind of an easy question this year. Super.